Hello everyone. In this tutorial we'll be going over how to make a axisymmetric 2D simulation in OpenFOAM. An axisymmetric 2D simulation is where is a 3D simulation that's axisymmetric, and the axisymmetry can be defined by a single plane. In OpenFOAM, as you might know already, won't handle purely 2D meshes, so it only handles 3D meshes. So it has a special boundary condition called wedge in order to make a small, thin 3D wedge into an axisymmetric 2D run. So here are the files we have for this tutorial: the case, the OpenFOAM case files, the mesh, and the results of the simulation that we'll run. So the simulation will be of a donut shape in freestream, and axisymmetric about the toroidal shape. So it's essentially a circle. We draw a circle and mesh that. So let's have a look at the mesh. So this is Gmsh. There's many ways you can make the thin wedge. As you can see here, it's a very thin wedge. You can but it all involves using the rotational extrusion command in Gmsh. So you can extrude it first and then rotate the whole thing so OpenFOAM requires that it's about 5-degree mesh where it's symmetric about a standard plane. For example, in this case, the Z plane is symmetric about the Z plane. So you can either extrude it first, then rotate the whole thing, or rotate your 2D plane, then extrude it. The latter is what we've done here. We create the 2D shape, and then we use rotate to rotate it 2.5 degrees in one direction, and then we use the extrude with the rotation encoded to extrude it the 5 degrees required. And then we recombine, of course, and it's only one layer. So yeah, that's pretty much there is to it. It's pretty simple. So the necessary boundary conditions we've defined are the wedge planes. That would be this plane here and this plane here, and of course the ring plane, which will form the donut as it is axisymmetric. So that'll be a wall, and then of course this outer wall, which we've defined as a slip wall, and the inlet and the outlet. And as you can see, we've defined all of these: ring, inlet, tunnel. Tunnel is the outer surface, the outermost surface. Outlet, wedge 1 and wedge 0. And that's all there is to it. So let's generate this mesh. Main.geo. Oh. Gmsh main 3 test.msh. So now test.msh contains our mesh, and let's convert it to OpenFOAM format. Case. Okay, successfully converted. Now let's go to the newly created boundary file and change what we need to change. So let's go into case, constant, polymesh. These were generated in the conversion, by the way. Okay, so now the wedge is a primitive type, so you want to assign those to wedge. Inlet, outlet, patches, tunnel, those are slips, so patch, and this is a wall. So that's all there is to it for the boundary file. Now, one more we are ready to run our simulation, but one more caveat is that in your controlDict you have a write format field. Usually in the tutorial cases it's ASCII, ASCII, but in this case it leads to the standard write precision leads to some inaccuracies in the plane directions. So if this is ASCII by default, then it's going to give you a whole bunch of errors complaining that the two wedges are not planar. So different points in them are not coplanar. So you should write it out. You should change this to binary so that the numbers in their full precision are written. Or you could alternatively, maybe, I haven't tested it myself, but you could probably bump up the write precision. But that's going to make your files a lot bigger, your mesh files. So I just elect to go with binary, and all the errors disappear and it runs smoothly. So let's now go into case and run our case with pimpleFoam. And as you can see, it's running along with no errors and very smoothly. So this takes a while, so I've already made a video for you guys to watch the results of. So here you can see our wedge mesh, and it's a pretty coarse mesh, but you know, good enough for the tutorial. And we have refinement near the donut wall, and there's a free stream coming down in this direction. So yeah, here's the evolution of the flow field around the donut. As you can see, you have the high velocity, low velocity in the front and back, and high velocity around the sides, as we'd expect. So yeah, that's how you do a simple axisymmetric 2D case in OpenFOAM. Thanks for watching, and happy foaming.